Hello guys, today I want to talk about DMVPN. In previous video I was talking about GRE tunnel, and I show you how can configure GRE tunnel. But the GRE tunnel that we config, it was point to point. It is that just for example here is Berlin, here is Hamburg. Just this tunnel can connect between 2 points and make the connection. But in our bigger organization, we have sometimes one central buildings, and we have so many branches, 10, 3, 5, up to the companies. There is new technology, there is another technology that we can use it point to multi-point. So DMVPN is point to multi-point, and between these connection, we can use different IP routing, EIGRP, OSPF, and BGP. We will do this configuration separated one time with EIGRP, another time with OSPF, and the last time with BGP. Then we will talk about that. What's the benefit of which one is better, which one was the positive point, what's the negative point. We will discuss about it. So now I want to start to configure it. Just before we start to do the configuration, I want to talk about the what is the phase 1, 2, and 3. Normally when we configure in the basic way, we just, for example, Hamburg want to contact to Munich, so Hamburg send the traffic to the center in Berlin. From Berlin goes in Munich, and it will return the reply to Berlin and goes to Hamburg. So this is hub and spoke, and it is phase 1. It means that everything goes directly here, and just through the central, all the traffic goes there, all the reply will goes exactly in central. But maybe for just few branches it's fine and it's okay, but normally when all these branches send the request, and the traffic in the central building will go high in hub, it will be so many traffic, so it's not the good way. So they will come and use another protocol, next hop resolution protocol, NHRP. And what's the NHRP exactly? We config in the hop and in the spokes some configuration that anytime that spoke wants to talk with another spoke, the spoke will come and send a request to the Berlin in the hub. I say sorry, central building or hub. And next hub resolution has a table. He shows the address of the branches that Hamburg want to contact. For example, Hamburg want to contact Munich. So first send a request to Berlin, and Berlin says that, okay, this is the IP of Munich. And after that, Hamburg will build a dynamic tunnel between Hamburg and Munich. And by this dynamic tunnel, they will contact directly. This is the good point, especially about the VoIP. In quality of service and the VoIP, always we are talking that VoIP as use UDP. It's always it's important that we be sure that all the data goes through the source and destination, and it will not any loss happen in data of the VoIP. So instead of Hamburg goes to Berlin, again to Berlin to Munich, they can directly communicate, and it's a good point, and there is no traffic goes through the central building. So I will start to configure it. Oh, sorry, just this was phase 2, and what's the phase 3? Phase 3, when we have a same configuration hub and a spoke, and we have another hub and a spoke 2, 3, 4. It is for scalable organization that they can use different several hub and spokes. So in phase 3, we add two commands, redirect and shortcut in hub and spokes. Just we add these commands. Then this spoke from this region can contact with another hub and spoke in another spoke directly. So make a dynamic tunnel building between this spoke and the spoke that belong to another hub and spoke. So that's the phase 3. Okay, let's start configuration. So I start to build the tunnel 1 and config the inside the tunnel 1. So I am going first. I start to config a hub. I go in tunnel 1. Okay. Now I save the configuration here. Just I am easy copy and paste it. Then I will explain it everything about it. I am using this IP address for the tunnel 192.168.1.0 with subnet 24, and it is recommended for the tunnels used /24 that we can make a 255 connections at least. So I paste this configuration. I will explain you now. Okay, in my previous video of GRE, you saw that when we configure a tunnel, we set the tunnel mode GRE. In point to point, we make it IPv4 or IPv6, but here we make it tunnel mode GRE multi-point because now it is point to multi-point. Just for the security, we make a key also to tunnel key. Then we add the keep alive. If you see my video, you know what is the meaning of keep alive. We set the MTU for stop the fragmentation happen in tunnel. TCP adjustment. So we know all these commands. Just now we have just a few commands is new. First of all, I will show you IP NHRP network ID. You can set any ID. For example, I say IP NHRP network ID. You can set from 1 to 42 million. I choose it 80. And then after that, I set a authentication, IP NHRP authentication. I put a commie. And this is important command that you must do it in hop. So IP NHRP, it says that for the dynamic tunnels, we must set it the NHRP map in multicast dynamic. So automatically can build a dynamic tunnel. This is all the basic configuration that we do it for the hub. Now I am going in spoke and start to configuration. So I am going in tunnel 1. Again, I copy the configuration. Oh, because before I copy, it's not just copy and paste. Here the IP I choose it 1 2 1 3 here and 1 4 here. So I choose sorry, this is a hop spot. I set it 1 2, and please attention, I here also I don't change this one because I choose all interfaces of the sources is same um, Ethernet 00, so I don't change it. I don't need to change it. But your attention, if you're in your scenario the source is different, you must set the correct source. Okay, so I choose it and then copy the configuration in tunnel. Okay, now let's check together. I told that tunnel source is F00, You can see here F00 source, mod GRE multipoint, tunnel key, IP MTU, keep live, adjustment, MSS, maximum segmentation, all address in hub was 1 1, here is 1 2, IP NHRP authentication, IP network ID, same as the hub, I set it. And this is the new command that you must set it in all the spoke. In all the spoke, you must set this one. This is says that when you want ask any NHRP for resolution protocol, NHS next hop server, we must add the IP address of the interface of the tunnel for the hub. Here, the tunnel, the address IP is 192.168.1.1. As we set it in the tunnel, this is the IP of the tunnel. Okay, and after that says that network broadcast multi-access. This protocol, please check about network broadcast multi-access to know it. This is the underlay IP address of the interface here. The interface of here, F00, if we can make a show IP interface brief, you will see that here is the IP is 8011. If you want, just I show you, do show IP interface brief. You can see the F00 here is 8011. So here I says that in this command and at the last multicast. So IP NHRP NHS, IP address of the tunnel, of the hub, NBMA, and the address IP of the underlay interface multicast. And now let's do we have access tunnels together. Can I ping to 1 1? Yes. So now between Munich and Berlin, the tunnel can pinging together. I will go and do same configuration, interface tunnel in another spoke, interface tunnel 1. This is for Frankfurt. Okay, I change here, make it 3. The other things is same as before, no need to change it. So I just paste it. I don't think that no need again explain all these things. This is all same. And just I try to ping 192.168.1.1. Yeah, everything's fine. And now I go in another spoke, configuration T, interface tunnel 1. And now here also just I change the IP, make it 4. Okay, copy and paste the configuration. Perfect. Now I do ping just for verification. 1 2. I have ping 3. I have access 4. Perfect. Now I must start to make a routing protocol, and we want to use for the tunnel DMVPN, we want to use for this video by EIGRP. So I go in router, EIGRP, I put it Cisco, address family, IPv4, autonomous systems, for example 10. Then I start to add the route of the tunnels and the loopbacks, that the route that we want advertise. I set a loopback 2 3 4 and 1 here, just for example to know how is the advertising. Here Berlin is the network of the IP tunnel is 10.0.0.0.255. Okay, I add it, and next, okay, start advertising. After that, I start to advertise 1111.0.0.0.255. I advertise the loopback of this one. Then I go here and router EIGRP Cisco address family IPv4 autonomous system 10. I add the network of the tunnel 168.1.0.0.0.255. Then yeah, the neighborship start network network. The in Munich is 222. So I add 222 0.0.0.255. Frankfurt exit router EIGRP Cisco address family IPv4 autonomous system 10. I add network of the tunnel. Oh, router EIGRP. Sorry. Okay, Cisco address family IPv4 autonomous system 10. Oh, I think there is before I set some things by mistake. Exit no router EIGRP. I make it by mistake. Add this one. Router EIGRP Cisco address family IPv4 autonomous system 10. Perfect. Network 192.168.1.0.0.0.255. I add the network for Frankfurt is 333 0.0.0.255. Perfect. Hamburg router EIGRP Cisco address family IPv4 autonomous system 10 network 192.168.1.0.0.0.255 and the loopback network 4.4.4.0.0.0.255. Okay, so yes, we have all the connection between all these by okay, all happened by the tunnel. So we have now neighborship of by this tunnel IP address, and let's check how is the IP route of EIGRP. Show IP route EIGRP. Yeah. See, in Berlin, we learned the loopback of 2, 3, and 4. 1 is belonging, if I get a show IP route, just normal IP route, you will see that 1 is connected, 2, 3, and 4 learned by EIGRP. This OSPF is between just the routers for the internet connections, everything. This OSPF, we don't want to talk about it. Just it's now about the tunnel we are talking. These tunnels, okay? Uh, okay, let's go in other branches and see show IP route EIGRP. Route EIGRP. Okay, interesting. This is just 1. There is no 2, 3, and 4. How about Frankfurt? Show IP route EIGRP. Perfect. Just 1. There is no other route. How about spoke up show IP route EIGRP. Here also just learn 1. Why Hamburg, Frankfurt, Munich just learn loopback 1 from Berlin? Berlin learn all the loopbacks 2, 3, and 4. Just think about it. Why the others didn't learn about it? Let me explain you by this way. We have a tunnel. This tunnel work like this. I'm not good in painting, so sorry. This is our tunnel. Here is tunnel 1, okay? Tunnel number 1 that we set it. Now Hamburg start advertising the loopback 444 for Berlin. Spoke to Frankfurt start advertising 33 to Berlin. Munich also start to advertise to Berlin. Berlin learn all these interfaces. But can Berlin start and advertise it the other routes that learned and they don't have it here? No. Why? Because of the split horizon. We have a split horizon in RIP and EIGRP. This is one of the mechanisms for loopback. Please learn more about the split horizon. Split horizon says that, let me clean here and just split horizon, the concept is that if this interface learn all these routes from this interface tunnel 1, interface tunnel 1 never advertise same routing that learn from same interface. This is the concept of split horizon, to stop the loop in the network. This is the mechanism that we before read about it. But here we know there is no loop. Just these branches, they are not directly connected, and no loop will happen. Here is the central building. These are branches, so everything just go. They are separated and they are not connected in any other way. And so there will no loop will happen by this way. So the matter that I want to do is I stop split horizon in the hub. Then when I stop the split horizon stop, then the other branches will learn the other routes too. Let's go to check it. I go in hub. We do only in the hub. We need to do it only in hub because all of these branches goes and ask from the hub any request they have. They want to communicate with any other spot, they will go here. So we just here we disable the split horizon. Before we saw in all these branches, just we learned router just loop back one, not two, not three, not four. So I go in Berlin, in configuration, router, EIGRP, Cisco, sorry, Cisco, address family IPv4, autonomous system 10, and here I want to go in interface of tunnel 1. So I am going in interface of tunnel 1 and says that no split horizon. I disable the split horizon. See, the neighborship again between the new relationship happen between them, between the hub and the spokes. You will see. Now let's check a show IP route EIGRP. Look, we learn the other routes. Munich learn not only 1, 3, and 4. How about Frank? Okay, before just was 1 because of the split horizon. Now we disable the split horizon, so learn 2 and 4. How about here? If we check it, now you will see 2, 3. Okay, perfect. So now all the branches can pinging together. Let's go, for example, in Hamburg. I want to ping to the here 222. 222. Yes, we can ping it. So between the branches, now they can ping and reach together. Okay, it's perfect. But now we want to try and understand another concept. Look at here in the route of Hamburg. If we want to go to the loopback 2, we reach to loopback 2. What is the address that we must go? 1 1. Here or other 3 1 1. So all the destination shows that here it is 1 1. But we know the source of the loopback 2 is 1 2. For 3 is 1 3. For 4 is 1 4. What is the concept of this that this route introduce just the IP of itself says that I am the source of this. If you want 222, come to 1 1 because of the mechanism of next hop self. When we run the next hop self shows that okay, just show my IP for this source, not the real source. So that's the matter. Because of this matter also, we must here in the interface of the tunnel 1, we disable next hop self also. Before I disable the next subset, look at this address. It is 1 1, it is 1 1 for loopback 3 and 4. Okay, now I disable again new connection. They renew the neighborship. Now check. Okay, here was all the addresses goes to 1 1, but now for 3 shows that the source of 3, the real source is 1 3. For 4 is 1 4. Before for 4 was 1 1. 3 was 1 1. So in hop, when we use EIGRP for DMVPN, it is recommended we disable two mechanisms. The first one is split horizon. Then second one is next hop self. And you know now why we do it, for which purpose. Okay, now let's see that our phase 2 that we config NHRP work or not. I do a trace route from Hamburg to the 222. I want to, okay, with the source of loopback 1. So from loopback 1, 4, we want to trace to 222 with numeric. Let's see what happened. Check. Uh, we are in Hamburg and we directly reach to 1, 2. What's the meaning of this? It means that when I request to reach to this address to the another spot, spoke to spoke directly start to connect it together. Just Hamburg for first time will contact with Berlin, and from the NHRP get the address of the Munich, and from Munich knows what is the address and start to connect directly. So no traffic go to the central. They can build a dynamic tunnel and they communicate directly. How about Frankfurt? For example, in Frankfurt, I want to trace. Here is 3. I want to trace 444, 444 with the source of loop back of 1. See, 444, 3 for the first time request. For the first time Frankfurt send a request to 11 and says that what is the IP address of the spoke that I want to connect. And Berlin shows it is 14. This is the first request. Look at the second time that we do it. For the second request never goes to 11 because learned 14. The Berlin told that this is the IP address of the spoke that you want to talk, and this route belongs to this IP address. So for the next time, this spoke directly make a dynamic tunnel and they communicate together. See, never go to ask from the Berlin. Go directly and make a tunnel directly between themselves. So I hope you understand about DMVPN in EIGRP when we use EIGRP, and what is the configuration, how we do config DMVPN by using EIGRP. Have a nice day. Bye.